Okay, math class, so this is a video for all the constructions that you need for the midterm. The first one is the perpendicular bisector. So we have a line right here, and in order to do the perpendicular bisector, you take your compass needle, put it on one end of the line, stretch your compass so that it's over halfway, make a semicircle here, do the same thing on the other side, and you keep it the same length, make another arc here. Now, where the two arcs meet is where you're going to take your straight edge. You're going to draw a line, and voila, the perpendicular bisector. So now that we just did the perpendicular bisector, we're going to learn how to draw the perpendicular line on a point that's written on the line already. So point P is where you want your perpendicular line to go through. Now, what you want to do is make it so that P is the midpoint. So you're going to put your needle on P, stretch your compass to the end, make an arc, then keeping your compass the same length, do the same on the other side, make an arc, and now P is in the middle of that line. So you're going to do the same thing as the perpendicular bisector. You're going to put your needle on one end, your pencil on the other, make two arcs, making sure you're keeping it the same length and going slightly past the midpoint, not on it. Then you're going to connect the two arcs. And now you have a perpendicular line through point P. So now we're making perpendicular lines through point P when P is above the line. So you're going to do something really similar. You put your compass needle on one end of the line, stretch it to point P, make an arc that goes downward, and do the same thing on the other side. You're going to have to change your length for this though, just keep that in mind. Bring the arc down. Then you're going to take your straight edge and put it through each line, and now you have perpendicular line through point P. So now we're shifting gears. We're going to be copying an angle. So here we have an angle that we are going to duplicate pretty much. I'm going to start off with a straight line, just with your straight edge, make a line on the paper, pretty simple. Now you're going to measure the distance between the two arrows over here. So you're going to put your needle on the vertex, then put your pencil at any length and just make an arc here. Now, keeping it the same distance, you're going to put it on the vertex of this line here, and then make another arc here. So now you need to measure the opening of the angle. You're going to put your needle on the bottom of the angle, then stretch your pencil to the top over here, and make an arc. Keeping it the same length, you put it on the bottom of the arc here, and where the lines intersect will be where the line goes through. So now you take your straight edge, your pencil, you go from the vertex of the angle through where the lines intersect, and now you have the same angle. So now our goal is to make a parallel line through point A on each line. So what you want to do is there's two ways. You can either copy an angle, or you can make two perpendicular lines. Now, I find the copying angle way to be harder, but you can do whatever way you would like. So you will put your ruler at any point on the line going through A. You're going to draw the line. Then you're going to take your compass, and just like we did in the last construction, put it on the vertex of the angle at any point you want. Measure it so that it arcs through both lines. Now once it does that, you do the same thing on point A, going through here. And now you need to measure the opening of this angle. So you put your needle on the bottom, pencil on the top, make an arc here. Now you do the same thing, you flip your compass around, keeping it the same length, put it on the intersection here, make an arc, and now you're going to take your ruler, which I just threw by accident, and put it through A and through these lines intersect. And now the lines are parallel, and you have a parallel line going through A. Now, the way that I find easier is this way, which is where, like we did before, we are going to make a perpendicular line through point A by putting our needle on one end, pencil on A, making an arc, needle on the other end, pencil on A, change the length, make another arc. So you're going to take your straight edge, put it through A, and make it go through the intersection. Now what you want to do is you're going to turn your paper, and you're going to make a line that is perpendicular to this line that we just drew that goes through A. So what you want to do now is the construction that we learned where we made A as if it was the midpoint. So we're going to measure this end, make an arc, turn it around and measure this end and make an arc. So I'm going to put my needle on the arc that we just made, go a little bit past the midpoint, make a nice big arc over here, keeping it the same length, and you're going to do the same thing make sure the arcs intersect at the top and bottom. Then you're going to take your straight edge and make sure your line goes through the intersection here, A, and the intersection at the bottom. And now you have a line that is parallel to your original line. This next construction is the perpendicular bisector. Now, this will divide your angle into two congruent parts. So the way we do that is we start by putting our needle on the vertex of the angle and drawing an arc just like when we were copying the angle. Make sure the arc goes through the top and the bottom rays. And you put your needle on the bottom intersection, pencil on the top, and just draw an arc here, measuring the distance. Now, keeping it the same distance, you're going to put your needle on this intersection and make an arc over here. And again, keeping it the same distance, you're going to put your needle on the bottom intersection and make an arc. Now, where these two lines intersect is where, with your straight edge, you are going to draw from the vertex through this X over here, dividing your angle into two parts. So now you have the angle bisector. So this next construction doubles as constructing both a equilateral triangle and a 60-degree angle. So it's kind of similar to drawing a perpendicular bisector, but same concept, but you don't put your needle or your pencil in the same spot. So what you're going to do is put your needle on one end of the line, pencil on the opposite end, you stretch it all the way, then you arc all the way up, making a huge arc here. Then keeping it the same length, you are going to make another arc here. Now, here's what happens when you draw the line from the end of here to the intersection. Make your line all the way up, which creates a 60-degree angle. Now, we know that equilateral triangles have all 60-degree angles, so what you're going to do is connect this. If you connect both sides to the vertex, you have an equilateral triangle. This construction is to inscribe a hexagon into circle O. So what you are going to do is put your needle on any point on the circle, it doesn't really matter where, and stretch your pencil to the radius or the center in the middle. Now you are going to mark the center here, make an arc, and with that same length, you're going to go around the circle, making arcs all the way around until you have reached the full circumference, and you'll see that you have 6 arcs now. So what you're going to do after that is take your ruler or straight edge and connect all of the intersections. And now you have inscribed a hexagon into a circle. If you wanted to inscribe an equilateral triangle into a circle, you would do the same thing, but only connect every other intersection. So it would look sort of like this. And now you have inscribed two shapes into a circle. These next few constructions will be for the points of concurrency of a triangle. Now, these kind of get a little messy, so I'm going to try and keep it as neat as possible. Now, the median of a triangle is when you construct the midpoint and then connect it to the opposite vertex of the triangle. So in order to construct a midpoint, or the median rather, you need to construct the midpoint. So you are going to make your midpoint construction that we went over earlier to mark the midpoint of the triangle here. So if you draw your line down through each of the intersections, where the two lines intersect here is the midpoint. Now if you take the midpoint and connect it to the opposite vertex using your straight edge, you now have a median. Now, the point of concurrency for the median is called the centroid. So if you do medians on all three sides, you will get the centroid. So we're going to turn our paper and repeat the same construction. We're going to connect this to the opposite vertex with our straight edge, and then turn the paper once again so that we can repeat the same construction a third time. Now, where all of these intersect, oh, sorry, I didn't draw the median over here, so you're going to connect this to the opposite vertex. Now, where all of these intersect, it may be a slight triangle in the middle, is where the centroid is, and this is how it is constructed. So right here, I am labeling it D for the centroid, and here you are. You can only construct two medians, and then it will make the centroid, and that is proven to be the centroid of a triangle. The centroid divides the median at a ratio of 2 to 1, meaning that this side is 2 times the length of this side, so it's x and 2x, and it's the same for all of these. And this is how you construct the centroid. So the next point of concurrency that we are going to do is the orthocenter, which is the point of concurrency for the altitudes of a triangle. Now, the altitude is a perpendicular line that connects the opposite vertex to a line that you are working on, which is using the same construction as we did when we did a perpendicular line above, through a point above the line. So point B here, we are going to make an arc, and then change our length and make another arc. And where those two intersect is where I'm going to draw my altitude. Now, in an isosceles triangle, the altitude is exactly in the middle, and in a right triangle, it turns out that where the right angle is where your altitude is on one of the legs. So now that we did the altitude once, we are going to repeat it on all of the other sides like we just did with the median construction. So I will just repeat that construction now. And we are going to repeat it one last time on segment BC. Now, where all these altitudes intersect is the orthocenter here, which I'm going to label D. So here you have the orthocenter. In an obtuse triangle, the orthocenter is outside of the triangle, and in a right triangle, the orthocenter is located on the vertex of the right angle, like I just told you. So here you have it, the point of concurrency for the altitudes or the orthocenter. Our third point of concurrency is called the incenter. Now, just as we learned before with the angle bisector, the incenter is the point of concurrency for the angle bisectors of a triangle. So angle B here, I'm going to do my angle bisector construction, making an arc, measuring the distance between each ray, and then going on the top arc, making another arc, keeping it the same distance on the bottom arc, and going from the vertex all the way through this X here. And you want to make sure you go through the opposite side of the triangle. It'll be much easier later. So I'm going to do that with all of the angles. Angle C, we are on the vertex. We make our arc, measure the distance. On the top arc, we will stay here. On the bottom arc, keeping it the same distance, making that nice X, and going through all the way to the other side. And our last angle is angle A on the vertex, making an arc, measuring the distance, and using the same distance to make an X on both the top and bottom rays. I know it's kind of hard to see, but this is the X that we just made here. So you're going to take your straight edge and go from A all the way through this X to create the final angle bisector. And where these points all meet is called the incenter. This is just the point of concurrency. I'm labeling it D like the past two examples, and there you have it, the incenter. Our last and final point of concurrency is the circumcenter, which is the point of concurrency of the perpendicular bisectors of each side of a triangle. So we've done this construction many times now. I'm just going to speed through this quickly. Perpendicular bisector of AC. Take your straight edge, put it through each intersection. Same for side AB. Putting it through the intersection here. And last but not least, side BC. Put your compass on the vertex. Make your arcs here. And finally, connecting each intersection. Now, where each one meets is called the circumcenter, and I am labeling it D. Here you have it, your final point of concurrency, the circumcenter. Like I said in the previous video, our next construction is a rotation around a point that is not on the shape. So in this case, we're rotating triangle ABC around point D. So similarly to what we did before, we're going to put our compass needle on D, which is our center of rotation. And A is our first point, so I'm going to stretch my pencil to A, measure it, and we're going to show that we measured it by making an arc. And keeping the same compass distance, we're going to go to our reference angle, which is 40 degrees, put our needle on the vertex, and make an arc that passes through both rays. Now you're going to put your needle on the bottom ray, pencil on the top ray, and make an arc here. And on point A, you are going to make an arc keeping the same distance. Now, since we're doing a positive rotation, we're going counterclockwise or to the left, and A prime will end up where these two intersect, and we will just label it like that. So we're going to do the same thing with point B. We're going to put our needle on D, pencil on B, make an arc to the left, keeping the same distance, put our needle on the vertex of the angle, and make an arc. Now, since my arc is obviously much farther than the two rays are, we just need to extend that line quickly. And like we did before with point A, we're just going to measure the opening of the arc by drawing an arc here and placing our needle on the bottom ray, keeping it the same distance. Put your needle on B, make an arc, and where the two intersect is going to be B prime. And lastly, we have C prime. So it's the same step a third time. Stretch your compass to C, make an arc, go on your reference angle, make another arc, and measure the opening one last time. And go from point C, intersect it with the previous line, mark point C, and then you just need to connect all of the points with a ruler or straight edge. And now you have you've rotated triangle ABC 40 degrees counterclockwise. This next construction is another transformation. It is called a translation, and we are going to translate triangle ABC along vector V. Now, the way we're going to do that is we are going to take our handy dandy compass and measure the distance or the length of the vector. So we're going to put our needle on one end, pencil on the other, and make an arc to show that we measured it. And keeping it the same distance, we're going to put our needle on A. And you kind of have to use common sense here. If the vector is going down and to the right, you're going to make your arc down and to the right. So now that we have an arc here, we're going to measure the distance between A and this point on the vector by putting our needle on A and our pencil on the point, and we're going to make an arc to show that we measured it. Then you need to take your needle, put it on the opposite side of the vector, and make an arc that intersects the arc that you just made. Where the two intersect will be A prime. And you're going to repeat this step for the next 2 points. So you're going to, again, measure the distance of the vector. Now we're going to do point B. We're going to make an arc. Then measure the distance from B to this point on the vector. And it does matter which point you do. You need to do B to the dot and not B to the arrow, or else it will not work. You measure the distance here. Place your needle on the arrow side and make an arc here that will intersect the other one. And then where it intersects, you're going to mark B prime. Lastly, we're going to do C, so we're going to measure distance of the vector, put our needle on C, and make an arc, extend our pencil to V, put our needle on the arrow, make another arc, and where the two intersect is where you are going to place C prime. And then you just need to connect all the points with a ruler or straight edge. And now you have translated triangle ABC along vector V to make it A prime, B prime, C prime. This last transformation we have is a reflection across segment M. So we're going to reflect triangle ABC, and we're going to use the same construction that we use for drawing a perpendicular line through a point above the line. So I'll show you what I mean when I say that. We're going to turn the paper so that it is vertical, and we have the line, our segment on the bottom, and our triangle on the top. Now, what I want to do is put my needle on one end of the segment and stretch to one point. I'm choosing point C, but you can choose whatever point you want. And the same way as if we were going to draw a line perpendicular to segment M, we're making an arc, and then we're moving to the other side, extending to C, and making another arc. And where these two intersect is where you are going to put point C prime. And you're going to do the same for the next 2 points. Now, obviously, I can't stretch my compass from here all the way to point A. So what I'm going to do is draw a point here. And I'm going to use these two in order to make a perpendicular line. So I'm going to put one needle on point M as if it was the end of the segment, because it's the end of this piece. I'm going to make an arc from A downwards. And I'm going to do the same thing on this point. I'm going to make an arc from A all the way down. And where the two intersect is going to be A prime. And lastly, we are doing a point B. So I'm going to put my compass needle on the end of the segment, put the pencil on B, and make an arc. And the same for the other side. Needle on the end of the segment, pencil on B, and make an arc. Where the two intersect is where we're going to have B prime. And now we're just going to connect these with a ruler or a straight edge. You'll notice that the orientation of the letters is the opposite. So if I'm reading the letters counterclockwise, you're going to be reading them clockwise and vice versa. So now you've reflected your triangle across this line. So these are the final two constructions that I have. What you're going to do is construct both a right triangle and an isosceles triangle. Now the way we're going to do that is we're going to start off with just a line, a straight line using your straight edge. Then in order to make a right triangle, you need a perpendicular line. So we're going to make a perpendicular bisector by drawing an arc that starts with our needle on one end of the line, and we stretch a little more than halfway, but not all the way towards the end and not on halfway. Then you're going to do the same thing for the other side, keeping it the same distance. And where the two meet is where you're going to draw a line with your straight edge. And now this line is perpendicular, so we can make a right angle sign here. And since we know this is perpendicular and we have two sides here, all we need to do is make the hypotenuse of the right triangle by connecting these 2 points. Now you have the right triangle, so this next one will be the isosceles triangle. So now we have the isosceles triangle. Last but not least, what we're going to do is start off with a straight line once again, using our ruler or a straight edge. And like the right triangle, we are also going to take our needle and put it on one side and stretch a little more than halfway, but not on halfway and not all the way, to make a perpendicular bisector We're going to do the same thing on this side. And where the two intersect is where you're going to draw the perpendicular bisector here. Now, in an isosceles triangle, both the median and the altitude are the same. So we know that the perpendicular bisector is the altitude of the isosceles triangle, and that these are right angles on both sides. Now, since it's a bisector, we know that both this segment is congruent to this segment here. And all you need to do to make this an isosceles triangle is connect these 2 points from this side to this side. And then you need to connect this point from here to the opposite end of your original segment. And now you have an isosceles triangle. So now we have the isosceles triangle. Last but not least, what we're going to do is start off with a straight line once again, using our ruler or a straight edge. And like the right triangle, we are also going to take our needle and put it on one side and stretch a little more than halfway, but not on halfway and not all the way, to make a perpendicular bisector. We're going to do the same thing on this side. And where the two intersect is where you're going to draw the perpendicular bisector here. Now, in an isosceles triangle, both the median and the altitude are the same. So we know that the perpendicular bisector is the altitude of the isosceles triangle, and that these are right angles on both sides. Now, since it's a bisector, we know that both this segment is congruent to this segment here. And all you need to do to make this an isosceles triangle is connect these 2 points from this side to this side. And then you need to connect this point from here to the opposite end of your original segment. And now you have an isosceles triangle. Hope you guys enjoyed this video, and I hope it helps you study for your midterms. Thank you all for watching.